students. I hope all of you are fine. I am back again with the second part of the complex number. Okay. So as I have promised, I am going to complete this chapter in 4 parts. So this is the second part, part 2 of complex numbers, which is covered in AA and AIHL 1.13. So in this session, I am going to teach you modulus and argument of complex number. Okay, only this part we are going to cover. Okay then, so let us start. You already know what is a complex number, right? So, a complex number, how to represent a complex number in a complex plane, that we are going to study today. Okay, that complex plane is also called as Argand plane or Argand diagram. Some books write it like that. So there is one-to-one relationship between any complex number z is equal to a plus bi or a plus b iota and the point AB. AB means the x coordinate A, y coordinate B. But here it will be the real part, it will be the imaginary part. Okay, A will be the real part, B will be the imaginary part in the Cartesian plane. So you already know the Cartesian plane. X-axis is the horizontal axis, y-axis is the vertical axis. So on the complex plane, the x-axis is called the real axis. Okay, we are going to call it a real axis, and the y-axis is called as imaginary axis. Okay, so this is the real axis. Okay, real, and this one is the imaginary axis. So any imaginary part will be calculated on the y-axis, any real part will be calculated on the x-axis. Okay, so I hope this is clear to you. Now, how to represent a complex number on the complex plane? So look at this first example. Z1 is equal to 2 plus 3i. Okay, so this lies in the first quadrant. Why? Because it has one-to-one relation with the number, the point 2 and 3, 2 comma 3. So somewhere here 2 comma 3 will be there. Okay, so Z1 2 comma 3, and let us join this with this. Okay, so this is the first complex number, 2 plus 3i. Z1 is equal to 2 plus 3i. I hope this is clear to you. Okay, now if you have to represent the second complex number, okay, Z2, which is minus 2 plus 3i, and as we know that it has one-to-one relationship with, okay, with the point minus 2 comma 3. Now according to the coordinate axis, the Cartesian coordinate system, 2 minus 2 and 3 will be in the second quadrant, and suppose it is somewhere here Z2, which will be minus 2 and 3. Okay, so this will be represented by this arrow diagram. Okay, I'll tell you about this. What is it? What does this represent? Okay, so Z2 is here, then Z3, the complex number Z3, which is 2 minus 3i, will lie in the third quadrant, and it will have one-to-one relation with the point 2 comma minus 3. Okay, so I'll locate it in the third quadrant. This is in the fourth quadrant, and this one is in the third quadrant. So let me correct it. Yeah, this is in the fourth quadrant, right? Yeah, as you know, positive, okay, positive x coordinate and negative y coordinate will be in the fourth quadrant, and then according to that this will be in the third quadrant. Okay, so let me correct my mistake. Yeah. Okay then. So this third one, Z3, lies in the fourth quadrant. The coordinates are related to 2 minus 3i will be 2 comma minus 3. So somewhere 2 comma minus 3 will be there. So suppose it is here, okay, Z3 2 comma minus 3, and it will be represented by this complex number, okay, and this arrow will represent the complex number Z3 on the complex plane. Then the last one, minus 2 minus 3i, will lie on the third quadrant, in the third quadrant, and it will have association with the point minus 2 comma minus 3. So somewhere minus 2 minus 3 will be there. So suppose it is here, Z4, which is minus 2 minus 3, and it will be represented by this arrow, okay. So these are the four complex numbers I have represented on the complex plane. I hope this is clear to you, okay. So the first one is Z1, which will be like in the first quadrant, 2 and 3. Z2, which is minus 2 and 3, will be on the second quadrant, in the second quadrant. Z3 will be in the fourth quadrant because I took Z3 as 2 and minus 3, and Z4 will be in the third quadrant, which is represented by the point minus 2 comma minus 3, okay. So I hope this is clear to you. Now let us again represent the other complex numbers which are purely real or purely imaginary, okay. Now look here, purely real complex number will have only the real part. It will not have the imaginary part. So it will be represented on the x-axis only. So therefore Z5 will be somewhere here on the real axis, Z5, okay. Then Z6, it has only purely imaginary part. So therefore it will be represented on the positive y-axis only, because it has only positive real part, imaginary part. Okay then, so I'll represent it somewhere here, which will be Z6, right? And then Z7, negative 4, is a real number but negative. So it will lie on the negative x-axis or negative real axis, you can call it, okay. So here also you can call it positive real axis, x-axis or positive real axis, okay. Let me write here real axis. So this is positive real axis, this is a negative real axis, okay, or I'll put it down better. So negative real axis, okay. So Z7, negative 4 will be somewhere here proportionately, Z7, okay. And then Z8, Z8 is negative 5i. So it is purely imaginary, but it is negative of the imaginary complex number. So it will be on the negative y-axis or negative imaginary axis, okay. Here also I can write positive imaginary axis. Yeah, I wrote x-axis and y-axis for your understanding, so no problem. So I'll represent minus 5i somewhere here, Z8. So Z8 is minus 5i, which will be on the negative imaginary axis, okay. Now note that a complex number z is equal to x plus yi is represented by the vector oz, which is given by the column vector x comma y. X is the real part and y represents the imaginary part. Okay. So a complex number can also be represented by a vector x y, column vector x y, because on the complex plane a complex number shows us the direction where it is. So actually a complex number z1 is from O to Z. Okay, it will lie from O to Z. Complex number z2 will be OZ2. Complex number OZ4 will be this one Z4, and Z3 will be complex number given by OZ3. Okay. So here I have represented the complex number z is equal to x plus yi, okay, by the arrow diagram which represents a vector. Okay. So a vector can also be represented by the coordinates x comma y or by a column vector x y. Okay, then now the complex conjugate. Okay, how to represent a complex conjugate on the complex plane? So if z is equal to a plus bi, then its conjugate is given by a minus bi. Okay, so it is represented as the reflection of z, okay, in the real axis, reflection of z in the real x axis or real axis. So suppose this is the complex number z, which is represented by the point a comma b. Okay, this is that complex number. Now its conjugate is represented as a reflection in the x-axis. So the real axis will be treated as a mirror line and the reflection of upper complex number will be below in the real axis, and it will be represented by a minus b, a comma minus b. So always remember, the complex conjugate of any complex number will be the reflection of that complex number z in the real axis. Okay, it will be the reflection in the real axis. So suppose if a complex number is here, okay, suppose w is here, minus 3 minus 2, then its complex conjugate will be the reflection in the real axis, which will be upwards, okay, above the real axis on the negative side, and here will be w conjugate. Okay, so I hope you will remember it. Yeah, or let me show it here permanently so that you can have it in the PDF. So here is w, which is -2, -3, then its conjugate, complex conjugate, will be the reflection, exact reflection of it in the real axis. And here, okay, here up you are going to have w conjugate, and it will be given by -2, +3, because we changed the imaginary part, the sign of the imaginary part, to write a complex conjugate, right? Okay, so I hope you understood how to represent the conjugate of a complex number. So please remember the thumb rule. For any complex number, if you are on the complex plane, if you want to represent its conjugate, take its reflection in the real axis, and that will represent its conjugate. Okay. Now the example is show the following complex numbers and their conjugates on a complex plane. So here it will be more clear to you. So I am going to show you all the four. Okay. So look here. First one, A part, I will do it here in this complex plane. So z plus 3i, this complex number z plus 3i will be in the first quadrant. So sorry, this complex number is Z1, which is equal to 4 plus 3i. Okay. So this complex number Z1, which is 4 plus 3i, I am going to represent in the first complex plane. So it will be somewhere here 4 on the real part and 3 in the imaginary part. So somewhere here it will be. Okay. So this will be Z1, which will be given by 4 comma 2, 4 comma 3, the point 4 comma 3, and it will be shown by this arrow diagram. Okay. Now its conjugate, I am going to represent its conjugate also. So it will be the reflection in the real axis. Okay. So 4 comma 3 will become, this 3 will become minus 3. Okay. So 4 comma 3 will become 4 comma minus 3, and it will be, let me make it big. So 4 is here like this, 4 and comma minus 3. Okay. So here will be that number or that complex number Z1 conjugate, which will be represented by 4 comma minus 3. Okay. And it will be shown by this arrow. Yeah. So I hope it is clear to you, the first part. Now look at the second part, B. I am going to show that B here, Z2 minus 2 plus 3i. So look here, minus 2 plus 3i. So it will be somewhere here. Okay. So I'll mark that point as Z2, which has the coordinates minus 2 comma 3. Okay. So this is that complex number. Yeah. Now its conjugate, because we have to represent conjugate of each one of them. Its conjugate will be what? Can you guess? See, we only change the imaginary part. So its conjugate, Z2 conjugate, will be given by, will be represented by the point minus 2 minus 3. Okay. Which will be reflection of Z2 in the real axis, which will be somewhere here. Okay. So I'll mark that point minus 2 minus 3. Okay. Somewhere here is that point Z2 conjugate, and the arrow will show it. Okay. So this is Z2 conjugate. So I hope you understood this also. So Z1 has Z1 conjugate, which is reflection in the real axis. Z2 has Z2 conjugate, which is reflection in the negative real axis. Then I will represent now Z3, which is only 2i. Okay. So Z2, Z3 only 2i, it's purely imaginary. Z3. Okay. Now can you guess what will be the conjugate of Z3? Well, we just changed the sign of the imaginary part, right? So there is only one imaginary part. So its sign will become negative 2i. Okay. And that will be the conjugate of it. So let me show you. So somewhere here negative 2 is going to represent Z3 conjugate. Okay. So I hope you understood this. This will be this arrow, and there it will be this arrow. Sorry. Yeah. Now this arrow will be like this. Yeah. Okay. Now I have to show you Z4. Okay. Z4, as you know, will be on the real axis only. So Z4, which is given by 3. So 3 is somewhere here. Z4. It will be given by this arrow diagram. Okay. Now the conjugate of Z4. Can anyone guess what will be the conjugate of this? Okay. So remember that we only change the sign of imaginary part. We don't change the sign of real part. So this will not have the conjugate, okay, because it is only the real part. So there will be no conjugate, only this will be the complex number, okay. So for only real part, if there is only real part and imaginary part is absent, there will be no conjugate, definitely. Okay then. Because there is a reason. How can you reflect this complex number which is having only real part? Where you will reflect it is on the mirror line itself. So it cannot be reflected, isn't it? Okay. Now come to this one. We can apply the vector operation of addition, subtraction and scalar multiplication to perform these operations with complex number, okay. So to add two complex numbers, you have to add them like vectors. As you add vectors like that, you are going to add complex numbers. So I want to tell you that vectors chapter was before this. So anyway, I am going to cover it later on. So I hope all of you know about vectors. Even if you don't know, I am going to show you here. Okay. So look here now. First I will show you where it will be and how they will be. So Z1 plus Z2. Okay. Now what is Z1? 4 plus I. So I have put here a graphics plane because we have to draw the actual diagram. Okay. So 4 on the real axis and 1 on the imaginary axis. So 4 here and 1 here. So this will be the place where it will go. Okay. This will be the place. So let me show you by arrow. Anyway, 1 minute. Yeah, this is that arrow now. Okay. So this is Z1. Let me mark it Z1. And then where Z1 will end, from there we will start Z2. Then only we can add them. Okay. So look at Z2. Z2 is minus 1 plus 3i. So let me make this big. Okay. Z2 is minus 1 plus 3i. Minus 1 means it will go to the left on the in the direction of real axis. I mean the horizontally. So let me label here also real axis, imaginary axis. Okay. So from here you will go in the negative direction 1 unit to the left and then 3 units upwards because it is positive. So 1, 2, 3. So it will come here. Okay. So it will be somewhere here. So 1 to the left and 1, 2, 3. It will come at this point. So I'll draw the arrow. Okay. Yeah. This will be your second complex number Z2. Now wherever it ends, join it with O and that will be your final result, the addition of two complex numbers. Okay. So here this will represent Z1 plus Z2. So now look here, this is that point which is going to represent Z1 plus Z2. What are the coordinates of it? 3, 4. This is Z1 plus Z2. Now I'll show you algebraically also because we have to show it by both methods, algebraic and graphics method. So look here, Z1 plus Z2. Z1 is 4 plus I and Z2 is 4 plus I plus Z2 is minus 1 plus 3I. Okay. When you add, you will add the real part because in the last lesson I have shown you, and you will add the imaginary part. So here is 1. In this place there is 1 only and in this place there is 3. So 1 plus 3 and I will be common with them. So again I'll explain you 4 the real part and minus 1 another real part, they will be added together. In the same way, for imaginary part, here is only 1, so it will be here, and 3i has only 3 imaginary part, so 1 plus 3. Now like that it will be 4 minus 1 3 plus 1 plus 3 4i. So look here, the diagram exactly represents the point 3 comma 4. So I hope you understood it. Okay. Now second complex, the second part of it I have to show you. So z minus 2i, it will be z1 minus 2 z2. Okay. So z1, first I will represent z1. Now look here, what is z1? z1 is 4 plus 4 plus I. Let me copy it here for our convenience. Yeah, z1 is here, and I will copy z2 also so that it is ready with us. Yeah. So these are z1 and z2. Okay. Now look here, z1 is 4 plus I. So 4 on the real axis, okay, and 1 on the imaginary axis. 4 here and 1 positive here. So here will be that first complex number. We had already shown this. This is represented by z1. Okay. So this is z1. Now 2z2. Look here, double of z2 I have to find out. So negative 2z2, because negative also. So negative 2 into minus 1 plus 3i, which will be given by 2 minus 6i. Yeah, is that clear to you? Minus into minus plus. So plus 2 and minus 2 into 3 plus 6, minus 6, sorry. Minus 2 into 3 minus 6. So 2 minus 6. Okay, this is my negative 2z2, all of it. So you have to draw all of it. So 2 in the positive direction where the first one is ending. From here 2 in the positive direction. Okay, so 2 units here, and then negative 6. So we will go down 6 units. So it means you have to come up to this negative 5. Okay, so that will become negative 6 units. Okay, so I hope you understood this. So positive 2 and negative 6, look here, positive 2 and negative 6 will come at minus 5. Okay, minus 5, because 1 unit is already here, and 6 units, for 6 units 1 unit is here and 5 units are here. So like that, total negative 6 units. Okay, so that will be our final destination of z2. So it will be something like this. Okay, it is not giving me arrow. Yeah, this is z negative 2 z2, because like that it is. So this is the final position. So I'll represent it like this. Okay, so here is our final position. So this arrow is representing z1 minus 2 z2. So I hope you understood this, and here the point is 6 comma negative 5. Now let us check it algebraically also. 6 comma minus 5, it is there or not? So z1 is 4 plus I minus 2 z2. I have already calculated it. So minus 2 into minus 1. Okay, minus 2 into minus 1. Let me write it properly. Plus 3i, and this will be 4 plus I plus 2 minus 6i, because minus I have multiplied. So both the real parts together 4 plus 2 and both the imaginary parts together. Okay. So like this. So like this I am getting z1 minus 2z2. So which will be finally 4 plus 2 6 minus 5i. And you can guess that it is represented by the point 6 comma minus 5. Okay. So which is correct here. Yeah. So I hope you will remember this. You will understand this and you will try the other questions. So z1 plus z2 conjugate. I am leaving it for you, or should I show? Let me show this also. So look here. Again, I have these two complex number. Let me bring them there so that they are ready with us. Yeah. Z2. Let me find Z2 conjugate because we have to use Z2 conjugate here. So Z2 conjugate will be real part as it is. The imaginary part will be negative 3i. Okay. So this is Z2 conjugate. So I hope you understood how I found the Z2 conjugate, right? Yeah. So this is my Z2 conjugate. Okay. Now to represent them, let me draw first Z1 on the complex plane. So this is the real axis, this is imaginary axis. Okay. Now Z1 is 4 plus I. So 4 and I, 4 plus I means 4 and 1. So it will go there. We have already used it. So I hope you understood. This is our Z1. And Z2 conjugate. Z2 conjugate is negative 1 minus 3i. So negative 1. Look here. From where it ends, I will go left 1 unit and then 3 units down. So at negative 2 I will reach. Okay. Minus 1, minus 3. So I am here now at this point. So this point is 3 and minus 2. Sorry, 3 and minus 2. Yeah. Here I am going to come from there. So this will be my Z2 conjugate, right? Why it is not making arrow? Yeah. So this is my Z2 conjugate. Let me label it Z2 conjugate. So the final result is from origin to this point. Okay. So this is my Z1 plus Z2 conjugate. And this is the point represented by 3 comma minus 2. So let us check it here. Okay. Z1 plus Z2 conjugate. So Z1 is 4 plus I plus Z2 conjugate is minus 1 minus 3i. So I'll write real part together plus the imaginary part together. Right? So look here. 4 and minus 1 together they are here. Okay. 4 is here, minus 1 is here, both the real parts. Then from imaginary part 1 is here and minus 3 is here. So like that 4 minus 1 3 plus, it will not be plus, it will be negative 2i. 1 minus 3 negative 2i. So look here, this is the point 3 comma minus 2. Okay. So I hope you understood this, right? Yeah. Now this is the exercise. I am putting it here. So I hope you will try this exercise. Okay. I will leave the graphical complex planes here. So okay. So you can try them yourself. Otherwise I will show it to you next time. Or should I show you one of them? Let me show you this one because it is Z1 plus 1. Okay. Now look here. Z1 plus 1 means what? A part. Z1 plus 1 will be represented by 4 minus I, okay, plus 1. So it will be 5 minus I. This will be the final result. But I have to show you by arrow diagram, okay, on the complex plane. So Z1 is 4 minus I. 4 to the right and 1 down. So look here, 4, now let me make it big, 4 and then minus I, okay. So it will come here at this point. So I'll mark it here. So this is my Z1, okay. Now from here I will have to add plus 1. Look here, plus 1 will be in the direction of real axis. So it will be a horizontal shift at 1. So from here I will go 1 unit to the right, okay, and this will be my final destination. So look here, this will be that real only part only. So Z1 and this is 1 only. So this is the final position. When I connect it with this, okay, so my final position will be Z1 plus 1, and which will be given by this point, which is 5 comma minus 1. And look at algebraic solution. This is also representing 5 comma minus 1. Okay. So I hope you understood this, how to represent this. Now this I am leaving it for you to complete in the homework. Okay. So I'll write here homework by red. Homework. Yeah, you should try some questions in the homework. If you don't get, please write it in the comment box. Okay, then I will solve them and send it to you. Okay, because some questions you should try yourself. Okay, now look at this. Here you have more of them. So this is also for the homework. I am putting it here. Yeah. So suppose Z1 is minus 2 plus 3i, Z2 is 1 minus 2i. Find using both algebra and vectors Z1 plus Z2 conjugate, 2Z1 conjugate minus Z2, Z1 conjugate minus 2Z2 and 3Z1 plus 2Z2. Okay. So I have put the 3 graphs here. So you can solve them here. Okay. So this is for A. This is the real axis. This is for B, part B. This is real axis and this is imaginary axis. Imaginary axis, and this is for part C. Imaginary axis and this is the real axis. Okay. And is there fourth one? Yeah, fourth is also there, D. So maybe you will say I am putting more for you. Let me check if something I should explain, then I will explain it to you. No problem. Yeah, I think all of them you can do, isn't it? 3, look at this, 3Z1 plus 2Z2. Okay, 3Z1 plus 2Z2. Let me show this here, D. So 3Z1, so minus 2 plus 3i is Z1. D part. Minus 2 plus 3i is Z1, right? And Z2 is 1 minus 2i. 1 minus 2i, okay? Yeah. So look here, what I have to represent? 3Z1 plus 2Z2. 3Z1 plus 2Z2. Okay. Now 3Z1. So directly 3 parts of Z1 I have to represent. So 3 times minus 2 plus 3i, which will be negative 6 plus 9i. Okay. And 2Z2. 2Z2 will be 2 into 1 minus 2i, which will be 2 minus 4i. Okay. Now look here, negative 6 plus 9i. 9 is not there on my graph. So I'll change my scale for this. I'll write here scale for real axis. 1 centimeter represents 2 units. And for imaginary axis also 1 centimeter represents 2 units. Then we can easily locate it. Okay then. So look here, minus 6 plus 9i. Minus 6 means in the negative direction 3, okay, because we have taken 2 units for 1 centimeter. So here I am minus 6 and plus 9. Plus 9 means half of 9, 4.5, okay. So 4.5 will be somewhere here in the middle, okay. So that is my point, minus 3 and 4.5. So 4.5, how many divisions are there? 1, 2, 3, 4, 5. So 2.5, okay. So minus 3 and 4.5 means between 4 and 5. So 2.5. This is my first complex number, which is, okay, which is 2z1. So let me write here 2z1. Okay, then, oh sorry, it is 3z1, not 2, 3z1, no problem. I'll change it to 3. Okay, then I have to show 2z2 where 3z1 is ending. Okay, 2z2. 2z2 is, look here, 2z2 is 2 minus 4i. Okay, so 2 in the positive direction and minus 4i will be downwards. So 2 means 1 unit to the right from here. So 1 unit to the right and 4 units down. So I'll go at 0.5 because from 4.5 we are coming down 4 units. Okay. So I'll be 1 unit here and 4.5 units down. So 0.5 units from real axis. Okay. So this is my final position. So let us mark it by the arrow. This is my 2z2. Okay. And this is my final position. So from origin I am going to come up to this. This is going to represent 3z1 plus 2z2. 3z1 plus 2z2. Okay. So let us write the coordinates of this here. What are the coordinates? So you have to take double of that. So minus, look here, minus 4 will represent minus 8 for the complex number, and half will represent plus 1. Okay. Now let us add algebraically and check whether our answer is correct. So 3z1 plus 2z2 will be minus 6 plus 9i plus 2 minus 4i. Now real part with real part, minus 6 plus 2, and imaginary part with imaginary part. So real part is here, the second real part is here, the imaginary part 9 is here, the imaginary part minus 4 is here. So now this is going to be minus 4 and plus 5i. Minus 4, what I wrote? Yeah, minus 4. 9 minus 4i will be 5i. Why it is like that? Let me check again. my first complex number, my first complex number 3z1 is minus 6 plus 9. Minus 6 plus 9 is here. Minus 6 plus 9 is this one, this position. Now I have to add into it 2 in the right direction, isn't it? By mistake I took 2 in the left direction, so no problem. I will erase this part. Okay, so this will not be my result. Okay, so look here, by mistake I had taken like that, so it should be plus 2, so 2 units to the right. Okay, 2 units to the right from minus 3 means minus 1. I will come here. 2 units means 1 centimeter on the graph, and minus 4 means 2 units down, only 2 units down from here. So from here 2 units down will be minus 1 and minus 2. So I will be between 2 and 3. So 2.5. Okay. From 4.5 I will come to 2.5. So it will be minus 4 down, because centimeter will be negative 2, minus 2 downwards. Okay. So 1 unit to the right. Okay. 1 unit to the right will be here, and means 1 centimeter, which will be 2 units, and 2 centimeter down, which will be 4 units. So from here 2 centimeter will be 2.5. So I will be at this position. Now it is correct. Okay, so this is my final position. So I am coming here. I don't know whether this arrow will be correct. I am here, and finally from origin I will be at this point. Okay, so this is 2z2, and this one, the final one, is 3z1 plus 2z2. Now look at this. What are the coordinates of this point? The coordinates of this point are minus 2 comma 2.5, minus 2 comma 2.5. Now you have to make double of it, because on the complex plane we have taken 1 centimeter is equal to 2 units. So double of each one will give you minus 4, and 2.5 will give you 5, positive 5. So which is here. Okay, so which is minus 4 and comma 5. So this is correct diagram. Okay, so I hope this is enough for today. I hope you understood. If you have any queries, if you have any comments, please write it in the comment box. Okay, so now I am going to end this lesson here. Okay, then bye for now. Okay, so I hope you will like my lesson, right? And you will enjoy it. I hope that you enjoyed it. Please like, share and subscribe my channel on YouTube. And if you have any comments, you can put it in the comment box. And if you have any queries, you can contact me on my email ID or contact me on my WhatsApp. The PDF of this file on which I have explained will be there on the link given in the description. Okay, then bye for now. Have a nice time.